Most organizations talk about Power Automate like it's a workflow tool. They are wrong. What they actually run is an automation control plane, a distributed decision and execution system that can write data, trigger approvals, move files, and wake up other systems at machine speed. Every flow is policy in motion, whether you admit it or not. That's why it works isn't success. It's the beginning of entropy. Outages, audit fights, invisible cost growth, and now AI agent Sprawl. This will give you the executive mental model first, then the enforceable mechanics. Low code is not low engineering. The foundational mistake is simple. Teams treat the flow ran as the definition of success. That definition works for personal productivity. A flow that renames files, pings a channel, or copies rows into a spreadsheet has consequences, but they're local. The blast radius is you, your team, and maybe a SharePoint library that nobody admits they own anyway. Enterprise automation is different. It creates side effects across systems you don't control, on identities you didn't design, under policies you haven't revisited since the rollout deck. And the platform will happily let you do it, because the platform enforces configuration, not intent. That distinction matters. Low code isn't less engineering. It's engineering without the cultural friction that normally forces someone to ask hard questions early. Who owns this? What happens when it fails? What happens when it runs twice? What happens when the connector throttles? What happens when the original maker leaves? In pro code, the difficulty of building forces design discussions. In low code, the ease of building removes them. So the organization gets what it optimized for: speed of creation, not quality of operation. Excellence in this context isn't how fast a team can assemble a flow. Excellence is repeatability under change. It's the ability to modify the automation when the business changes, when the connector changes, when the API changes, when identity rules change, when regulators change their mind, when Microsoft changes a default, and they will, constantly. A flow that works today but cannot survive change isn't a solution. It's deferred incident response. Now, the predictable pushback is, but low code is supposed to be agile. Governance slows it down. That's the comfortable story. It's also how governance becomes a cleanup project instead of a design constraint. Governance can't be bolted on after adoption, because the critical decisions are made at creation time. Which environment, which connectors, which identity, which data path, which ownership model, which logging surface, which retry behavior, which permissions. Those aren't decorations you add later. They are the physics of the system. Once you let the estate form organically, the estate hardens. You get thousands of small, convenient decisions that become permanent architecture, and every exception you tolerate becomes an entropy generator. Shared accounts, personal connections, flows that nobody can explain, retrees that hide root cause, branches that create non-enumerable behavior. This is why executives should care, even if they never open the Power Automate portal. Automation becomes operational dependency quietly. It doesn't announce itself as a tier 1 workload. It just shows up in the business process. Invoices route faster, requests get approved, onboarding happens, records sync, notifications go out. Then one day it doesn't, and suddenly a workflow tool outage is a business outage. Executives also care because cost becomes unpredictable, not because the platform is malicious, but because uncontrolled execution pathways create churn, flows that rerun, loops that burn calls, retrees that multiply load. The business didn't ask for more transactions. The automation manufactured them. And then there's audit defensibility. Auditors don't care that the maker had good intentions. They care that the organization can explain what happened, who approved it, what data moved, what identity performed the action, and what controls prevented the wrong thing from happening. When an automation estate grows without a model, the audit answer becomes, we think this flow did it, but we're not sure. That's not a process gap. That's a control plane gap. Architects should care for a different reason. Low code turns architectural debt into security debt faster than most platforms. Because flows don't just compute. They execute. They create, delete, update, approve, and notify. They are distributed write access with a friendly UI. When that access becomes unowned, you are no longer managing apps and workflows. You are managing orphaned authority. So the correct posture is not to stop low code. That's not happening. The correct posture is to treat it like what it is, an enterprise automation layer that needs the same things every execution system needs: clear intent, bounded blast radius, deterministic execution, observable behavior, and enforceable ownership. This episode starts with the mental model because without it, patterns sound like personal preference. Once the model is clear, the patterns feel inevitable. And that's the point. Next, the system needs a name, because when you call it a workflow tool, you govern it like a hobby. When you recognize it as a control plane, you govern it like infrastructure, what the automation control plane really is. Calling Power Automate a workflow tool is like calling Entra ID a login screen. It's not wrong exactly. It's just the wrong level of abstraction. The system you're operating is an automation control plane, a set of distributed controls that decide who can do what, with which data, through which connectors, in which environments, under which policies, with which logs, and with which failure behavior. That definition matters because it forces the right question. Not can we build the flow? Should this flow exist? And if it exists, what does it get to touch? In platform terms, the control plane is everything that shapes execution without being the business payload: identity, connectors, environments, data loss prevention policy, managed environments, solution packaging, connection references, environment variables, audit logs, and admin analytics. The data plane is the actual work. The message, the document, the record update, the approval, the ticket, the email, the API call. People obsess over the data plane because it's visible. Incidents are caused by the control plane because it's implicit. Here's what most people miss. Those pieces don't operate independently. They compile together into one machine. Identity is not just authentication. In this system, identity is authority. A connection is a delegated permission boundary. A connector isn't a convenience. It's an integration contract with its own throttles, behaviors, and failure modes. An environment isn't a folder. It's an isolation boundary with its own policy surfaces. DLP isn't a compliance checkbox. It's the connector graph you're allowed to traverse. ALM isn't bureaucracy. It's how you prevent someone clicked save from becoming a production change. And audit logs aren't history. They're your only defensible explanation when something goes wrong. The uncomfortable truth is this: Power Platform does not enforce your intent, it enforces your configuration. If you didn't encode the boundary does not exist. Your org chart does not exist. Your risk appetite does not exist. Your "that's not how we do it" does not exist. Only configuration exists. That's why policy exceptions are entropy generators. Every time someone says, just this once, let them use that connector, or just let the flow run under my account for now, the platform does not record your reluctance. It records the exception. Then the exception becomes normal because it works. Then it gets copied. Then it becomes template. Then it becomes the estate. Over time, the control plane drifts away from your original assumptions. Missing policies create obvious gaps. Drifting policies create ambiguity, and ambiguity is where incidents live. So when this episode says control plane, it's not being poetic. It's describing a real operating model: intent, decision, execution. Intent is what leadership thinks they bought. It's the business contract: what must happen, what must never happen, what data must not move, what identity must never approve its own work, what changes require review, what actions are considered side effects, what the blast radius is allowed to be. Decision is where you interpret intent against reality. This is classification, routing, triage, exception handling, and increasingly AI reasoning. It's probabilistic by nature. It makes guesses, it prioritizes, it may be wrong. That is not a failure. It's the design. Execution is where you must stop guessing. Execution is deterministic. It is rights, approvals, notifications, record creation, file movement, permission changes, side effects. Execution must behave like an industrial machine: consistent inputs, consistent outputs, bounded retries, and an audit trail that can survive an incident review. When you mix decision and execution in the same flow, you create conditional chaos. Probabilistic reasoning glued directly to deterministic side effects. That's how you get duplicate emails, double created tickets, conflicting updates, and we don't know why it ran. And because the control plane is distributed, the chaos scales. A single bad retry policy isn't local, it becomes load on shared services. A single unowned connection isn't private, it becomes orphaned authority. A single DLP exception isn't isolated, it becomes a new pathway for data movement. This is the core misalignment. People design flows as if each flow is a self-contained script. In reality, each flow is a node in a tenant-wide authorization and execution graph. The platform compiles that graph from your configurations, whether you understand them or not. So the goal now is not better flows. The goal is a control plane that produces predictable automation, intent expressed clearly, decisions isolated where uncertainty belongs, and execution constrained where side effects happen. Once you adopt that model, excellence stops being a motivational word. It becomes a mechanical property you can enforce. Excellence as an architecture, not a goal. Excellence is usually where organizations hide vagueness. They say it when they mean we want fewer incidents, or we want to scale, or we want the auditors to stop asking questions. But in automation, excellence isn't a value statement. It's an architectural property. If the automation behaves deterministically under change, you get excellence. If it doesn't, you get entropy. And the platform doesn't care what you intended. It just runs what you built. So define excellence in terms the control plane understands: deterministic behavior, bounded blast radius, and explainable failure. Deterministic behavior means the same input leads to the same side effects. Not usually, not unless it retried, the same. When a run produces different outputs depending on timing, connector mood, or how many other flows are hammering the tenant, you don't have an automation system. You have a slot machine with admin permissions. Bounded blast radius means one automation can't take the rest of the estate with it. It can fail, it can be throttled, it can hit an upstream outage, but it cannot amplify into a tenant-wide performance incident because someone built an unbounded loop and called it robust. Explainable failure means a human can answer quickly what happened and why, not with folklore, with artifacts, a run history that reads like a narrative, a correlation ID that ties orchestration to execution, and an audit trail that doesn't require a multi-day archaeological dig through nested scopes and renamed actions. This is why executives should care. Automation doesn't stay in the productivity category. It becomes embedded in revenue processes, customer operations, compliance workflows, and financial approvals. Quietly. Then it becomes politically impossible to turn off. That's the trap. Leaders end up running a production system that nobody designed as a production system. And when an executive asks, why did this break? The worst possible answer is because someone changed a flow. That's not an explanation. That's an admission that change control never existed. Architects should care because this platform converts complexity into security debt faster than most engineering teams can track. Not because makers are reckless, because the system makes it easy to create authority pathways without understanding them. A flow with the wrong connector and the wrong connection reference isn't just misconfigured, it's a new write capability edge in your authorization graph. It can move data, it can approve, it can delete, it can exfiltrate, and if you can't name who owns it, you can't bound it, and you can't explain it, then you can't defend it. So excellence is not better standards. It's a model that makes failure boring. Now here's the part most people miss. Excellence collapses in 3 predictable ways. Not because of bad people, because of system behavior. First, complexity. Flows accrete logic. Every exception becomes a branch. Every branch becomes another run shape. Eventually you can't enumerate behavior. Testing becomes theater because you can't prove you covered all paths. The system still runs, but you no longer know what you're running. Second, capacity. Power. Automate lives in multi-tenant services with shared limits and throttles. Your flow isn't alone, and it doesn't execute in a vacuum. When teams treat retrees as reliability or loops as just how you do it, they manufacture load. Then they get throttled. Then they retry harder. Then they call it a platform issue. It isn't. It's uncontrolled execution pathways. Third, ownership. Automation estates outlive their creators. People move roles. Contractors leave. Teams reorganize. But flows keep running because the business now depends on them. When ownership decays, authority becomes orphaned, incidents become untraceable, and audit questions become existential because the organization can't even identify who is responsible for the thing that moved the data. Those 3 failure modes, complexity, capacity, ownership, aren't independent. They compound. Complexity hides capacity waste. Capacity incidents trigger retrees. Retrees create more complexity. And when ownership is unclear, nobody has the mandate to refactor, so the estate just accumulates more entropy generators. Everything clicked for most experienced platform teams when they stopped chasing good flows and started enforcing one architectural pattern that collapses complexity later. There is one pattern that turns a chaotic estate into a readable one. It's not a naming convention. It's not a training session. It's structural. And it starts with admitting that branching everywhere is not flexibility. It's conditional chaos. Next, that chaos gets a name, because once you can name it, you can kill it. Anti-pattern 1 said Christmas tree flows. Christmas tree flows are what happen when a flow becomes the place the business goes to negotiate with reality. They start innocent, a trigger, a couple of actions, and a condition. Then someone adds an exception, then another, then a retry just to be safe, then a switch to handle special customers, then a loop because the data shape changed, then a scope because the loop fails sometimes, then an approval because someone got nervous, then another branch because approvals time out. And suddenly the flow isn't a workflow, it's a policy argument expressed as nested containers. The symptoms are obvious when someone is brave enough to zoom out. One mega flow, branches in branches, conditions inside loops inside conditions. Decision logic mixed with execution steps so tightly that you can't tell which part is figuring out what should happen and which part is actually doing the thing. And it ends in multiple places. Multiple terminate actions, multiple send email actions, multiple create record actions depending on which branch you happen to fall into that day. That's not flexibility, that's non-enumerable behavior. Here's why it happens. The UI makes branching cheap. When the business asks for just one more case, the maker doesn't need to redesign anything. They just add a condition. The platform rewards this with immediate success. The run turns green. Everyone celebrates. No one asks what was traded away. What was traded away is explainability. Every new branch creates a new run shape. Every new run shape creates a new set of possible side effects. And because decision and execution are interwoven, you can't reason about blast radius locally. A change to a routing rule now sits next to a delete file action in the same container stack. So teams start testing, or what they call testing. They run the happy path. They run one exception. They run one more. Then they ship. Because enumerating all paths is impossible once the tree gets wide enough. At that point, testing is a ritual that makes people feel responsible without producing certainty. That distinction matters. Christmas tree flows don't fail in clean, diagnosable ways. They fail as ambiguity. The wrong branch triggers. A variable gets set in one path and referenced in another. A condition doesn't match because the data is null in one scenario. A connector returns a different error shape, a scope catches something it shouldn't, and now the run history looks like a choose-your-own-adventure novel written by 5 different people across 2 years. So mean time to explain goes vertical, not because people are incompetent, because the artifact is not explainable. The flow is a maze. Debugging becomes archaeology. Expand a scope, scroll, expand another scope, scroll again, check which branches ran, and then try to infer intent from action names like condition 12 and compose 4. And yes, the operational metrics get worse in exactly the way you'd expect. Mean time to explain moves from minutes to hours to days as the tree grows. Change failure rate rises because every branch multiplies the number of ways a small edit can create an unexpected side effect. And deployment time increases non-linearly because nobody wants to touch it. Every change feels like surgery on a live system without imaging. The punchline is the most uncomfortable part. If one flow handles everything, nobody owns anything. Ownership doesn't survive ambiguity. When the flow contains every business rule, every exception, every connector quirk, and every workaround, no single team can claim responsibility for the whole thing. Maker say I should own it because it's critical. I says the business should own it because it's business logic. Security says everyone should own it because it moves data. So in practice, nobody owns it, and the control plane behaves accordingly. Unowned systems don't get refactored, they accrete. There's also a hidden governance failure in the Christmas tree. It collapses the boundary between decision and execution. That means a change to how we classify can change what we write in the same edit. The system stops being deterministic at the exact layer that must be deterministic. So when people say we need standards, what they really mean is we built a tree and now we can't explain it. The fix isn't heroic, it's structural. Collapse branching, separate decision from execution, and force a single readable run shape. But before the patterns show up, the next cliff appears. Because even a perfectly readable tree still burns capacity, and the platform always collects its bill. Anti-pattern 2, API exhaustion by convenience. API exhaustion is what happens when a team treats execution like it's free. It isn't. Power Automate looks like a canvas. Underneath, it's an engine making calls into shared services. Microsoft 365, Dataverse, SharePoint, Teams, Exchange, third-party APIs, and whatever else someone connected at 2 a.m. because it unblocked the business. The anti-pattern shows up in 3 behaviors: unbounded loops, unnecessary runs, and retries used as a personality trait. Unbounded loops are the obvious one. Apply to each over hundreds or thousands of items with actions inside that loop that were never designed to run at that volume. And the maker doesn't see a cost meter. They see green check marks. So the loop grows, the scope grows, and the action count multiplies. The flow still works until it becomes a noisy neighbor inside your own tenant, and then everyone gets to pretend it was unpredictable. Unnecessary runs are quieter and more damaging long-term. Trigger fires on every update, every email, every record change, and then the flow immediately discovers it didn't need to run. So it terminates. People call that guarding. It isn't guarding. It's paying for noise and then congratulating themselves for exiting politely. Real guardrails happen before the run exists. Trigger conditions that prevent the run in the first place, and upstream filtering that reduces volume before you ever enter execution logic. Anything else is just log pollution with a side of capacity burn. Then there are retries. Retries are not reliability. Retries are a policy decision that trades load for the illusion of resilience. Here's the weird part. Most retry behavior doesn't make a system more reliable. It makes it less explainable. The original failure gets buried under cascaded attempts, partial success, duplicate actions, and timing variance. You don't get one incident, you get a swarm of related incidents, each one handled, but none one fully understood. That's how you end up with the worst kind of automation failure. Not it broke, but it kind of worked twice. Architecturally, API calls are shared capacity and a governance surface. That's the reframe. When one team's flows burn through connector calls, they're not just consuming their own budget. They're competing inside multi-tenant services. And multi-tenant services don't negotiate. They throttle. Throttling isn't Microsoft punishing you. It's the platform telling you your execution pathways are unbounded. But most teams interpret throttling as the platform is flaky. Therefore, they add more retries. Therefore, they create more load. Therefore, they get throttled harder. Conditional chaos, but at the capacity layer. This is where causation matters. The incident isn't caused by scale. Scale is just volume. The incident is caused by uncontrolled execution pathways, flows that run when they don't need to, loops that expand without ceilings, retries that multiply pressure, and designs that treat connector calls like internal function calls. They aren't. They're network operations with quotas, latency variance, and service-side limits you do not control. Executives should care because this is how automation produces hidden cost growth. The business didn't ask for 5x more transactions. The automation manufactured them. Extra runs, extra calls, extra retries, extra duplicate writes, extra downstream reconciliation. And the cost isn't only licensing, it's operational. teams burning hours chasing intermittent latency spikes, explaining why nothing changed right before it failed, and writing compensating flows to clean up the duplicate mess the first flow created. The most uncomfortable truth is also the simplest. Most automation capacity incidents are self-inflicted, not because people are careless, because nobody put a ceiling on execution and the platform will not infer one for you. The platform enforces configuration, not intent. So if you didn't encode this flow may call this connector at this rate with this maximum fanout with this retry policy, then the system's default behavior becomes your architecture. And defaults are not an architecture, they're entropy with good marketing. The fix later will look boring. Budgets, trigger discipline, bounded retries, and design patterns that keep loops from turning into denial of service against your own tenant. But before that, there's a bigger problem than cost. Unowned automation doesn't just burn capacity, it burns accountability. And that's the next cliff. Anti-pattern 3, shadow automation. Shadow automation is the part of the estate nobody wants to admit exists, because admitting it forces a governance conversation that should have happened 2 years ago. And it's not the same thing as shadow IT. Shadow IT mostly stores data in the wrong place. Annoying, risky, usually recoverable. Shadow automation executes. It moves data between systems. It creates and deletes records. It sends messages that look official. It approves things. It opens tickets. It closes tickets. It changes permissions. It does side effects at machine speed, with no human in the loop, and often with no one left who remembers why it was created. So the core symptom isn't secrecy, it's the absence of ownership. It looks like temporary flows that have been running since the last reorg. Flows built for a project that ended, but the flow stayed alive because nobody wanted to be the person who turned it off. Automations that are owned by an individual user account because it was faster than getting a service account. Connections that use someone's personal mailbox, someone's personal SharePoint permissions, or a connector authenticated by a contractor who left 6 months ago. And because it still runs, everyone pretends it's fine, until it isn't. Here's what most people miss. In Power Automate, the connection is authority. If the connection still works, the flow still has permission, even if the human behind that permission has moved roles, lost context, or left the company. That is orphaned authority. And orphaned authority accumulates silently because the platform doesn't feel shame. It doesn't ask, are you sure this still makes sense? It just continues executing your past decisions. Shadow automation is also why incident attribution collapses. When something breaks, the question is simple. What changed? In a healthy system, you can answer that. There's a release, a deployment, a version, a ticket, a change record, a known owner, a rollback plan. In shadow automation, you get none of that. The flow is in the default environment. It has been edited by 3 people. It uses a connector nobody remembers approving. The run history shows that it succeeded 9,000 times, failed 200 times, and retried another 400 times. Then someone asks, is this flow still needed? And the room goes quiet because needed is now undefined. And that is how audits become painful. Auditors aren't hunting for elegance. They want defensible control. Who owns this automation? What data does it touch? What identity executes it? What prevents it from doing the wrong thing? And how do you stop it quickly during an incident? Shadow automation fails every one of those questions. No owner means no escalation path. No escalation path means incidents become group therapy. Or worse, a team's thread where everyone says not us, until the business impact forces someone to take ownership temporarily, which is the enterprise version of hot potato governance. It also creates duplicate actions in a way that feels like a platform bug, but isn't. 2 flows solve the same business problem because nobody had visibility into the first one. An old flow keeps sending notifications after a process changed, so a new flow gets built to correct the message, and now customers get 2 emails. A record is created by one automation, updated by another, and then corrected by a third because the schema changed. None of them are malicious, they're just uncoordinated. And uncoordinated execution is indistinguishable from failure. Security teams experience shadow automation as a different kind of nightmare. You can't do least privilege retroactively when you don't know what the automation was meant to do. You can't rotate credentials cleanly when the connection lives in a personal context. You can't prove data residency controls if you can't even inventory which connectors are in play. So the punchline lands hard, and it's true. Shadow automation isn't hidden, it's just unowned. And because it's unowned, it becomes an authority surface no one governs. Over time, those surfaces accumulate. More connections, more permissions, more exceptions, more just make it work fixes. That's how low-code turns into distributed authority sprawl. The immediate instinct is to solve this with cleanup. Inventories, reports, deletion campaigns, naming conventions, maybe a center of excellence email that says, please assign an owner. Those help, but they aren't structural. The structural fix is to make ownership and authority explicit in the architecture, not implied by who clicked create. Which means the next step isn't another policy document. It's a mental model that forces the right separation. intent, decision, execution, so ownership and authority attached to the execution layer, where the side effects actually happen. The executive mental model, intent, decision, execution. So here's the model that makes governance stop sounding like opinion, intent, decision, execution, not as a diagram to impress a steering committee, as a way to stop automation from turning into conditional chaos. Intent is the business contract. It's what leadership believes the automation is for, and more importantly, what it must never do. This is where risk appetite lives in plain language. Which data can move, where it can move, which approvals can be automated, which approvals must not be automated, what good looks like, what unsafe looks like, what the kill switch is, and who's allowed to pull it. Intent also defines the boundary of responsibility. If the automation touches HR records, that isn't a workflow. That's regulated behavior with legal consequences. If it can create a vendor, approve a payment, or change access, that's not productivity. That's control. And if leadership can't state the intent as a contract, then the platform will invent it from whatever configuration the builder happened to choose. You already know how that ends. Decision is the interpretation layer. This is where ambiguity belongs. Classification, routing, triage. Is this request valid? Which team owns it? Is this high risk? Is this a duplicate? And yes, this is where AI reasoning fits, because reasoning is probabilistic. It makes judgments, it uses patterns, it may be wrong, it may change its mind when the model changes. That is not a bug, that is the nature of decisioning. The critical rule is simple: decisions can be uncertain. Execution cannot. Execution is the side effect layer. Writes, deletes, sends, approves, creates, grants access, moves files, opens tickets, closes tickets, everything that changes the state of another system. And because execution creates irreversible consequences, it must behave deterministically. Bounded retries, idempotency, audit trail, and compensation when something partially succeeds. If you can't explain what it did and you can't prove it did it once, you don't have automation. You have a liability with a green check mark. This separation is why the earlier anti-patterns are not bad design. They're category mistakes. Christmas tree flows collapse decision and execution into one tangled artifact. API exhaustion happens when execution has no budget, no ceilings, and no guardrails. Shadow automation happens when execution is allowed to exist without explicit ownership and authority. Intent, decision, execution fixes all three because it creates enforceable seams. Intent becomes a review surface. Does this automation align to a business contract? And is there a named owner accountable for the contract? Decision becomes an isolation surface. If the decision logic changes, it doesn't automatically change the execution behavior. It produces a decision output, an explicit classification or instruction, so the rest of the system can treat it as data, not as branching chaos. Execution becomes an enforcement surface. All side effects occur behind a deterministic gate that can be tested, audited, throttled, paused, and replaced without rewriting the world. And here's the part executives usually appreciate once it's stated plainly. This is not more process, it's how you make automation survivable. Because over time, intent changes, decision logic evolves, and connectors get updated, throttled, deprecated, or replaced. If those changes directly mutate execution behavior, every change becomes a production risk. If execution is isolated and deterministic, change becomes local, explainable, and reversible. Architecturally, this is the same separation every high-scale system eventually rediscovers. Policy versus mechanism, planning versus actuation, orchestration versus execution. Power Automate doesn't exempt you from that. It just makes it easy to pretend you can skip it. You can't. So the working definition becomes: intent tells you what must happen and what must never happen. Decision tells you what you think is happening right now. Execution does the minimum set of side effects once with proof. That model also gives you an immediate governance payoff. You can assign different accountability to each layer. Business leadership owns intent. Product or operations owns decision criteria and routing outcomes. Platform and engineering owns deterministic execution units, capacity budgets, and audit defensibility. No more shared guilt, real ownership. Now that the model is clear, the patterns stop being stylistic preferences. They become the mechanics of enforcing separation at scale. Next comes the practical architecture that makes this separation visible in every run history. Direct path thinking, thin orchestration, and execution units you can actually govern. Pattern, direct path architecture. Direct path is what happens when you stop treating a flow like a decision tree and start treating it like an execution pipeline. Most makers build wide because the canvas invites it. Every exception becomes a branch. Every branch becomes its own little world. And pretty soon, the run history is 8 different stories depending on which path you triggered. That's the Christmas tree problem. Direct path flips the shape. One endpoint. Minimal nesting. Decisions expressed as data. Execution expressed as a linear sequence that can be read top to bottom without expanding containers like you're spelunking. The uncomfortable truth is this: humans don't debug trees well. They debug narratives. A direct path flow reads like a narrative. Guard, classify, set context, execute units, terminate once. When it fails in a place you can point to. When it succeeds, you can explain why it succeeded without, well, it depends which branch you hit. That distinction matters. Direct path isn't less logic. It's logic moved out of branching and into explicit decision outputs. Instead of forking execution into 10 different branches, the flow decides once, stores the decision as a small set of values, then runs the same execution sequence with conditional no-ops where appropriate. In other words, decision doesn't create endless execution forks. Here's the architectural rule that makes it work. Decision can be complex. Execution must be simple. So a direct path orchestration flow does a few things well. It validates inputs early. It normalizes data into a predictable shape. It produces a decision artifact, classification, route, risk tier, whatever your domain uses. And then it calls deterministic execution units that perform side effects. If a given execution unit doesn't apply, the flow doesn't branch into a new universe. It just doesn't call that unit. That's how you collapse the number of run shapes. And the number of run shapes is directly correlated to mean time to explain. When you have one dominant run shape, the run history becomes readable. When the run history becomes readable, incident response becomes mechanical instead of interpretive. This is also why direct path isn't a developer preference. It's a governance enabler. A single endpoint gives you one place to enforce termination semantics, one place to stamp a correlation ID, one place to emit consistent logging, one place to apply a kill switch pattern, one place to measure latency and retrieve without doing forensic math across 20 branches. Executives like direct path for the reason they rarely articulate. It localizes impact. When a flow branches wildly, a small change can affect anything. When a flow stays on a direct path, a change typically affects one decision output or one execution unit. That's the difference between deployments are scary and deployments are boring. And yes, there's a measurable impact. MTTE drops because you stop scrolling through nested scopes trying to figure out which branch ran. Change failure rate drops because you're not duplicating actions across branches and forgetting to update one of them. And deployment time drops because people stop treating the flow like an artifact you don't touch unless you're desperate. Now, the common objection is, but branching is how you model real business complexity. No, branching is how you hide business complexity inside execution. Direct path still supports complexity. It just forces you to express it in one of two acceptable places, upstream in decisioning or downstream in isolated execution units. The main orchestration stays thin and readable because its job is not to be clever. Its job is to be explainable. This is where the diamond versus direct path idea is useful. But the lesson isn't the geometry. The lesson is that collapse is a design choice. You can build a flow that spreads and then reconverges, and that's already better than the Christmas tree. But the direct path goes further. It avoids the spread in the first place by turning different outcomes into different data, then using that data to call the right execution units. So the orchestration stays narrow, and narrow is governable. One more subtle payoff, direct path forces ownership boundaries to become explicit. When execution happens through child flows or execution units, you can assign owners to units, set API budgets per unit, and control side effects with policy. You can't do that when everything is buried inside one megaflow's branches. So if you want automation excellence to be a property of the estate, not a hope, direct path is one of the few patterns that makes the estate converge toward readability instead of drifting toward conditional chaos. But a pattern is only real if the organization can enforce it. And enforcing it requires the next discipline, design before build, so the path is intentional before the canvas tempts you into entropy. Design then build, the minimum viable design discipline. Direct path sounds like a pattern problem. It isn't. It's a design problem that shows up as a pattern problem because people build before they decide what they're building. And the platform encourages that. Power Automate's canvas is optimized for momentum, trigger, action, condition, done. The UI rewards movement. It doesn't reward intent capture. So teams treat design like paperwork, something you do after the flow exists when you already know it works. That is backwards. In an automation control plane, design isn't documentation. Design is the act of declaring boundaries before the system turns your defaults into architecture. If you don't declare boundaries, the platform will. And it will choose convenience every time. So the minimum viable discipline isn't a 40-page document that nobody reads. It's a short design step that forces the uncomfortable questions early while the flow is still cheap to change. The simplest useful design artifact has 4 parts. First, scope. What problem is this automation solving and what problem is it not solving? This sounds obvious until you watch a flow absorb just one more thing for 2 years. A written scope is not bureaucracy, it's a stop sign that prevents Christmas tree growth from becoming culturally normal. Second, systems touched, not SharePoint and Teams. Be explicit. Which tenant services, which line of business systems, which external APIs, which data stores. Because every system you touch adds throttles, failure modes, and audit obligations you don't get to ignore later. Third, data movement. What data crosses boundaries and which boundaries matter? Internal to the tenant, across environments, out to third parties, into email, into chat, into files. Whenever data moves, risk increases. That's not fear, that's physics. And if you can't explain data movement in one diagram, you don't understand what you're building. Fourth, the security conversation starter. Which identities execute the side effects? Service account, service principal, delegated user connection, managed identity where available, what roles are required, what DLP boundary applies, and what the kill switch is, not we can disable the flow. A real kill switch, a control you can activate without editing the flow under pressure. Those 4 parts take an hour, not a week. But they surface the true bottlenecks before build begins. This is where enablers matter. In personal automation, the maker owns everything. Their mailbox, their SharePoint access, their connectors, their licenses. In enterprise automation, the builder doesn't own the prerequisites. They need service accounts, premium licensing approvals, connector reviews, environment access, sometimes even firewall or conditional access alignment. If you don't identify those early, you don't build faster. You just hit a wall mid-build and start hard coding to get unstuck. That's how production gets poisoned. Temporary connections become permanent, environment variables become hard-coded values, and "we'll fix it later" becomes the estate's architecture. Minimum viable design also forces non-functional requirements to exist as control surfaces, not as vague wishes. Latency. How fast does this need to complete, and what happens when it doesn't? Resiliency. What failures are acceptable, and what failures require a human? Audit. What evidence must exist after execution, and where is it recorded? Identity. What is the least authority required to perform side effects, and how is it reviewed? Those aren't nice to haves. They're what make deterministic execution possible. And yes, this is where you deliberately separate scaffolding from production. The scaffolding flow exists to discover unknowns. It can be verbose, inefficient, instrumented for visibility, but it must still sit on the right foundation. Correct environment, correct identity model, correct connection strategy, correct DLP boundary. Otherwise, the learning you do becomes unusable, because the moment you migrate to production controls, the flow behaves differently. That is the hidden cost of skipping design. You validate the wrong thing. Design then build is not about slowing makers down. It's about preventing the platform from converting prototype shortcuts into permanent control plane debt. Because without design, the organization doesn't actually move faster. It moves earlier. It ships sooner, then pays later. During outages, during audits, during mergers, during connector deprecations, during identity hardening, during the moment someone realizes the flow that runs payroll notifications is authenticated with an employee's personal account. So the rule is simple. If you can't describe the automation before you build it, scope, systems, data movement, identity, you're not building an automation. You're generating an incident artifact. And once you accept that, the next step becomes unavoidable. Every side effect needs a deterministic gate with transaction semantics. Not because engineers like ceremony, because execution creates consequences, and consequences require design. TDD redefined, transaction-driven design as mandate. This is where the conversation stops being philosophical and becomes enforceable. TDD in this episode does not mean test-driven development. Nobody is asking citizen developers to write unit tests in a drag-and-drop canvas and pretend that's the same thing. TDD here means transaction-driven design. And it's a mandate because enterprise automation is not logic. It's transactions across systems you don't control, with side effects you can't unsend. A transaction, in plain terms, is any automation step that changes the state of the world in a way that matters. Create a record, update a record, delete a record, send an email, post a message, create a ticket, approve something, change access, move a file. If it produces an external consequence, it's a transaction. Everything else is preparation. Here's the uncomfortable truth. The platform makes it trivial to create side effects, but it does not guarantee transaction semantics. It will happily run twice. It will happily retry. It will happily partially succeed, and it will happily leave you with a run history that says failed after it already sent the email and created the record. That distinction matters. So, transaction-driven design starts with a simple rule. Every side effect must be treated as a transaction. And every transaction must have 3 properties: idempotency, an audit trail, and a rollback or compensation plan. Idempotency means if the same transaction runs twice, the outcome is still correct. Not mostly correct. No duplicate tickets. No double approvals. No duplicate emails that trigger customer escalations. No double writes that corrupt downstream reporting. If your automation can't be safely rerun, you don't have reliability. You have a one-shot script pretending to be infrastructure. Audit trail means the automation leaves evidence that a human can use to explain what happened later. Not just the flow succeeded. Evidence, correlation IDs, transaction IDs, the target record identifiers, and the decision output that led to the execution. Because when incidents happen, you won't be debugging code. You'll be defending actions. Rollback or compensation means when the transaction partially succeeds, you have a defined behavior to restore correctness. Some systems support true rollback, most don't. So in practice, compensation is the pattern. Create a reversing action, mark a record for remediation, reopen a ticket, post a corrective message, or move the item into a quarantine queue with human review. The point isn't perfection, the point is bounded harm. This is why this is executive grade. A duplicate email is annoying. A duplicate approval is a control failure. A duplicate record in a financial system is audit exposure. We don't know if it ran twice answer is not operational uncertainty. It's governance failure. Transaction-driven design makes that failure impossible to normalize because it forces every builder to declare where side effects happen and how they're contained. Now connect this back to the model. Intent, decision, execution. Transaction-driven design is the execution layer discipline. It's the thing that keeps probabilistic decisioning from bleeding into irreversible actions. Decision can be wrong, execution cannot be sloppy. So instead of treating send email as just another action, you treat it as a side effect with semantics. You ask, what is the unique key for this event? What proves we sent it? What stops a retry from sending it again? Where is the evidence stored? What happens if the connector times out after sending but before returning success? Because yes, that happens and the platform will not solve it for you. This is also where execution units come from. An execution unit is the smallest chunk of automation that performs one business-relevant side effect set with an explicit input contract and explicit output evidence. Think of it as a function with receipts. It takes a payload plus a transaction identity, performs the side effect once, and returns a result you can log and reason about. Orchestration should call execution units. It should not perform side effects directly because orchestration is where variability lives: routing, branching, exception decisions, retries, and timing. Execution units are where determinism lives. This is the design move that changes everything without hype. You stop building flows as process diagrams. You build them as a set of transactions with proofs. And when you do that, you gain a control surface executives actually understand. You can measure how many transactions exist, who owns them, what data they touch, what their API budgets are, and whether they can be safely rerun. That's not developer elegance, that's governance you can audit. Deterministic scaffolding, prototype without poisoning production. Most organizations skip a phase. Then they act surprised when the prototype becomes production. The missing phase is deterministic scaffolding, a working proof that deliberately trades efficiency for visibility while refusing to compromise the foundation. That distinction matters. A scaffolding flow is not an MVP. An MVP ships and accumulates obligations. Scaffolding exists to answer unknowns: connector behavior, data shape, latency variance, throttling patterns, and the one error condition nobody documented because it only happens on Tuesdays. Scaffolding has one job: make the unknowns obvious before they become outages. But scaffolding fails when teams treat it as a shortcut around governance. They build it in the default environment. They authenticate with personal connections. They hardcode URLs and IDs for now. They skip DLP conversations because it's just a prototype. Then when it works, the organization congratulates itself and asks to just put it in prod. And now you're trapped because the foundation is wrong. The prototype validated a configuration that production will not allow. Or worse, production will allow it because nobody enforced the boundary and the prototype's bad assumptions become permanent. So deterministic scaffolding has a non-negotiable rule: foundation first, changeable layers above. The foundation is the control plane, environment strategy, identity model, connector boundaries, connection references, environment variables, and the minimum logging surfaces you need to prove what happened. Those choices must be production aligned even in scaffolding because changing them later is expensive and destabilizing. It's like building a house on sand because it was faster than pouring concrete. Everything on top of that can be ugly. In scaffolding, efficiency is deferred by design. You accept redundant actions, you accept extra logging, you accept verbose run history, you accept waste that makes behavior legible. Because early in a build, the expensive thing isn't API calls, it's uncertainty. Teams love optimizing early because it feels like competence, but early optimization is how you hide the very signals you need. Which step is slow, which connector times out, what the actual payload looks like, how often the trigger fires, which errors are transient, which are deterministic, and which are just your own logic failing. Visibility beats elegance during discovery. So the scaffolding flow should be opinionated about observability. It should stamp a correlation ID immediately and propagate it through every call, every child flow, every record write, every ticket, every message. Not as decoration, as the thread you'll pull during incident reviews. It should log decision outputs as data, not as branching logic. If there is routing or classification, capture it explicitly so you can compare what we decided to what we executed. That becomes the evidence trail later when someone asks why a particular downstream system changed. It should validate inputs early and fail fast when inputs are invalid, rather than limping forward and generating partial side effects. A prototype that kind of works is how you get the worst production incidents, half-completed transactions with no compensation plan. And yes, scaffolding should plan for exception handling without implementing every last branch. This is where most makers do the opposite. They add exception branches early because they're nervous. The flow becomes a Christmas tree before the core path is even stable. Then they can't see what failed because the error is swallowed in a scope that handles it by sending an email to someone who never reads it. Deterministic scaffolding plans the exception model as structure. It reserves a place for it, a quarantine path, an escalation unit, a compensation unit, and a clear terminate with reason behavior. But it does not implement a dozen bespoke exceptions while the core execution shape is still changing, because early exception handling usually encodes wrong assumptions. It treats symptoms instead of causes. So when does scaffolding become production grade? There's a pivot point, and it's not when the business likes it. It's when the unknowns are resolved and the run shape stabilizes. Inputs are predictable. Connector behavior is understood, transaction boundaries are defined, and the decision outputs are explicit. At that point, you refactor. You remove visibility-only noise. You implement bounded retries as policy, not habit. You replace broad queries with targeted filters. You convert repeated blocks into execution units. You enforce direct path shape intentionally. And you do it before users depend on it. Because once users depend on it, every refactor becomes politically expensive and operationally risky. The scaffolding hardens, the shortcuts become architecture, the incident gets scheduled for later. Deterministic scaffolding is how you keep that from happening. It preserves the one thing low-code destroys by default: the ability to learn without accidentally shipping your learning into production. Pattern: orchestration thin, execution thick. Deterministic scaffolding solves the prototype became production problem, but it doesn't solve the bigger problem. Most estates still put the wrong responsibilities in the wrong place. They build orchestration flows that are thick with side effects, connector quirks, retries, and data mutations. Then they wonder why every change feels dangerous. This is the pattern that corrects that drift. Orchestration thin, execution thick. Orchestration is not where work happens. Orchestration is where work gets authorized, shaped, and routed. Execution is where side effects happen, once, with proof. That distinction matters because it gives you an architecture you can govern, not a canvas you can decorate. A thin orchestration flow has a tight job description. It does 4 things, and it does them predictably. First, it triggers and identifies the transaction. It stamps a correlation ID immediately because without correlation you don't have observability, you have anecdotes. Second, it applies guardrails, validate inputs, enforce intent boundaries, check eligibility, short-circuit early when the contract isn't met, not by terminating later, by preventing useless execution upfront. Third, it does routing and produces a decision artifact, not branching chaos. A small, explicit output, root, risk tier, action list, classification, something you can log, audit, and replay. Fourth, it delegates. It calls execution units that do the real work. And that's it. If orchestration starts performing writes, approvals, file moves, or ticket creation directly, it's no longer orchestration. It's a Christmas tree in training. Execution thick means the opposite. The execution units carry the weight. An execution unit owns the side effect. It owns idempotency. It owns bounded retries. It owns connector-specific failure behavior. It owns compensation. It produces evidence. It returns an outcome that can be logged and reasoned about. So when a connector changes behavior, you update the execution unit. When an API starts throttling, you tune the unit. When the business wants an additional side effect, you add a new unit or extend an existing one with a contract change. You don't rewrite the orchestration narrative. You don't multiply branches. You contain change where change belongs, at the side effect boundary. This is also how you avoid the most common low-code trap: business logic mixed with connector mechanics. In a thick orchestration flow, you'll see things like, if customer is tier 1, create a ticket, then post to teams, then update Dataverse, but only if the SharePoint call returns 200 unless it times out, in which case retry 3 times unless it's Friday, then email finance. That isn't business logic, that's connector behavior welded to policy, and over time it becomes impossible to tell which part of the flow exists because the business asked for it, and which part exists because the platform misbehaved once and someone patched around it. Execution thick forces that separation. Business logic expresses intent and decision outputs. Execution units express mechanics, how to reliably write, send, create, or update, under the constraints of real services. Now the best part, ownership becomes assignable. A thin orchestration flow can be owned by the process owner or platform team because it's mostly stable. It triggers, validates, routes, and delegates. Execution units can be owned by the teams that actually understand the side effect domain. The Dataverse team owns write customer record. The ITSM team owns create incident. The messaging team owns notify teams channel. Security owns grant access. Finance owns create vendor with controls. That's not politics, that's accountability aligned to authority. And because execution units are isolated, you can bound blast radius. If the create ticket unit starts failing or getting throttled, you can disable or degrade that unit without taking down the entire orchestration. You can quarantine, you can fall back to manual, you can stop side effects without losing intake visibility. This pattern also quietly sets you up for the agentic future everyone is rushing into without the discipline to survive it. Decision agents belong upstream. They classify, triage, recommend. They live in the decision layer where probabilistic behavior is acceptable. But the moment an agent crosses into execution, writes, deletes, approvals, everything must snap back to deterministic controls. Execution units become the airlock. Structured inputs, strict permissions, bounded retries, and evidence trails. So when people say, we want AI to handle more, the correct architectural response is, fine. But it will only talk to execution through deterministic units that you can audit, throttle, and kill. Orchestration thin, execution thick is how you keep autonomy from becoming conditional chaos. It's not a stylistic preference, it's entropy management. And once it's in place, child flows stop being a convenience feature. They become the execution architecture. Pattern. Child flows as execution units. Child flows are where most Power Automate estates either become governable or they become a distributed mess with nicer diagrams. Used correctly, child flows are not reusable chunks. That's the beginner framing. Architecturally, they are execution units, the deterministic boundary where side effects happen with contracts, controls, and receipts. That distinction matters because orchestration thin, execution thick only works if execution is actually separable. Child flows give you the seam. Here's the simple version. A child flow should behave like a function. Clear inputs, clear outputs, predictable behavior. No hidden dependencies. No, it reads a variable that happens to exist upstream. No, it grabs context from whatever connector the parent used. Inputs in, side effects, evidence out. And once you treat child flows that way, three things become possible that were basically impossible inside a mega flow. First, reuse without duplication. The Christmas tree anti-pattern duplicates actions across branches. Create ticket exists in 4 different places, because each branch needed it slightly differently. That's how you get drift. One branch gets updated, the other doesn't, and now the system behaves differently depending on which path you hit. A child flow collapses that. There is one create ITSM ticket execution unit, one write dataverse record unit, one send notification unit. If behavior changes, it changes once. The estate stops forking itself. Second, testing becomes real. Power Automate testing inside a giant flow is mostly theater because you can't isolate behavior. Everything is coupled. To test one side effect, you must trigger the entire process, hit the right branch, and hope the dependencies behave. With child flows, you can test an execution unit directly with controlled inputs. You can rerun it, you can confirm idempotency. You can validate error handling, you can prove that a retry won't double write. That's not pro-code purity, that's incident prevention. Third, governance becomes enforceable. This is the payoff executives and auditors actually care about. If all side effects live inside child flows, you can apply rules at the execution boundary. Who can own and edit execution units? Which connectors are allowed inside execution units? What identity is permitted to execute them? What logging must be produced? What the retry policy is? What the compensation path is? A child flow becomes a control surface, a place you can enforce intent through configuration, because you've made the place where intent turns into action explicit. Now, there's a trap here, and most teams fall into it. They turn child flows into microflows for everything. One child flow to pass JSON, one to set variables, one to format a string, one to check a condition. 50 child flows later, nobody can trace execution, and the run history becomes a set of nested invocations that reads like a dependency graph designed by a committee. That isn't modularity, that's sprawl with better naming. So the rule is blunt. Child flows are for side effects. If the step doesn't change the state of another system, it probably doesn't deserve to be an execution unit. Keep orchestration thin, but don't fracture it into nothing. The orchestration still owns intent enforcement, decision output, correlation, and delegation. Execution units own transactions. That also means child flows need contracts. Inputs should include the transaction identity, correlation ID, business key, whatever makes idempotency possible. If you can't dedupe, you can't safely retry, and if you can't safely retry, you'll eventually ship duplicate side effects under load. Outputs should include receipts, the record ID created, the ticket number, the message ID, the status code, the timestamp, the decision context used. Because it succeeded isn't evidence, it's a feeling. And yes, ownership gets cleaner. You can assign execution units to domain owners, you can version them, you can ring-fence updates. You can run change control on the units that actually create blast radius instead of policing the entire canvas. This is how you convert Power Automate from a bunch of flows into an automation control plane. Not by centralizing everything, by standardizing the boundaries where authority turns into action. And when those boundaries exist, something else becomes possible. You can stop paying for noise at runtime. because now you can terminate early, enforce trigger discipline, and keep the orchestration path readable while execution stays deterministic. That's next. Pattern: terminate early and stop paying for noise. Most Power Automate estates don't have a performance problem. They have a willingness to execute problem. The platform will happily run your flow for every event you allow it to see. It will run it when the email is irrelevant, when the record change is cosmetic, when the attachment is missing, when the payload is empty, when the customer ID is null, when the request is obviously a duplicate, and when the status already equals the value you're about to set. Then it will give you a run history full of green check marks and polite terminations. And you will pay for all of it: capacity, API calls, connector quotas, log volume, and human attention during incident response. So this pattern is simple: terminate early and stop paying for noise. But terminate early has two different meanings, and most teams only implement the expensive one. The expensive version is let the trigger fire, run 10 actions, then realize you didn't need to run, then terminate. That's not early, that's late with manners. The cheap version is prevent the run from existing. Trigger conditions are the actual guardrail. They block the run before the engine spins up. They keep run history clean. They reduce capacity burn. They prevent noisy neighbor behavior inside your own tenant because the automation never joins the competition for shared resources. And this is where governance becomes real. If you don't enforce trigger discipline, you are accepting uncontrolled execution as your default. You are choosing entropy. Once a run exists, early termination still matters, but it's a second line of defense. This is where one-sided conditions earn their keep, not branching logic, escape hatches. If the input doesn't meet the contract, terminate with a reason code and stop. If the item is already processed, terminate and stop. If the decision layer classifies the request as manual review, terminate and hand off. If the downstream system is in a known outage state, terminate and quarantine rather than hammering it with retries. That's deterministic behavior. The flow exits on purpose, not by accident. This pattern also fixes a subtle audit and operations problem: ambiguous runs. When a flow runs and does nothing, it still leaves a trace. But that trace is confusing. Auditors and incident responders see a run and assume it mattered. Operations teams see hundreds of daily runs and can't distinguish meaningful execution from noise. So they either ignore the logs, which is what everyone does until the day they can't, or they waste time interpreting runs that should never have existed. Noise is not neutral, noise is cost and confusion. So the architectural rule is, if a run will do nothing, it shouldn't run. That means pushing conditions as far upstream as possible. Filter at the trigger, filter at the connector query, reject before loops, reject before child flows. And if you're calling execution units, don't call them just in case. Call them only when the decision artifact says they apply. Now, about retries, because teams keep using retries as therapy. Retries are not a developer convenience. They're part of your reliability policy, and they belong to the execution layer, not the orchestration layer. Orchestration should not retry side effects blindly. Orchestration doesn't know if the side effect already happened. It only knows it didn't get a clean success response. Retrying at orchestration is how you manufacture duplicates. Execution units can retry because they can implement idempotency. They can check whether the transaction already applied. They can bound retries by policy. They can back off. They can emit receipts. They can stop. That's the difference between resilience and churn. So the rule is blunt. If you can't prove an action is safe to retry, you're not retrying. You're doubling down. And when you stop paying for noise, the platform's behavior gets less mysterious. Latency becomes explainable because you're not competing with your own useless runs. Throttling becomes a meaningful signal because you're not flooding connectors with irrelevant calls. Run history becomes readable because most runs now represent actual work, not a trigger that fired because someone edited a description field. Executives will like this pattern for the simplest reason. It produces immediate cost control without a replatforming project. You reduce wasted execution, you reduce connector pressure, you reduce operational churn, and you get cleaner metrics because your dashboards stop measuring activity and start measuring outcomes. Architects will like it because it restores determinism. The run shape becomes consistent, the path becomes readable, the execution surface becomes bounded, and governance teams will like it because it creates enforceable standards that are easy to audit. Does this flow have trigger conditions? Does it have explicit escape conditions? Does it avoid null runs? Does it enforce bounded retries at the transaction boundary? That's how you turn terminate from an action into a design principle. Next, there's an even cheaper way to stop paying: eliminate actions that never needed to exist in the first place by doing work in expressions, not API calls. Pattern: expressions before actions. Expressions before actions is the point where a low-code estate either grows up or it keeps paying an invisible tax forever. Because actions aren't steps, they're calls, they're latency, they're quota consumption, they're run history noise. And they're a governance surface you just expanded for no reason. The platform makes actions feel cheap because they're draggable. But the execution engine doesn't care about your canvas. It cares about how many operations you asked it to perform and how many external systems you pulled into the transaction. So the rule is simple. If the platform can compute it locally, don't outsource it to an action. That means use expressions to transform data, choose values, and shape payloads before you start calling connectors, especially in loops, especially in orchestration, especially anywhere the flow could fan out under load. Here's what most people miss. A condition block is not just logic, it's a container. Containers create nesting. Nesting hides behavior. Hidden behavior increases mean time to explain. And if the condition exists purely to set one value, you didn't need a container. You needed an expression. This is the common example. Two nearly identical email actions, one for case A and one for case B. Because the recipient or subject changes, that's not branching, that's duplication. One email action can handle both if you compute the to and subject using an if expression. Now you have one place to change the template, one place to log evidence, and one place to enforce execution rules like emails must include correlation ID. Branching is how you create drift. Expressions are how you keep execution narrow. Same logic applies to variable spam. Power Automate makes it easy to set variables. So teams set variables for everything. Store the output, store the intermediate value, store a flag, store a string they could compute at the point of use. And every variable set is another action, another log entry, another opportunity for confusion, and another place for somebody to temporarily change behavior. Most of the time, the data is already accessible. The platform's outputs are effectively global within the run. You don't need to copy a value into a variable to use it later. You just need to reference it. When you do use a variable, it should be because the value genuinely changes over time and you need that state. Not because you wanted a label. That distinction matters because variables are where accidental complexity hides. The flow stops reading like an execution narrative and starts reading like a memory game. Then there's filtering, which is where estates light money on fire without even realizing it. If you see get items and then filter array right after, you're usually looking at waste. You pulled too much data, then you paid more actions to throw most of it away, and then you looped over what's left anyway. Filter upstream, use the connector query options where they exist, reduce the payload before it enters your flow. The cheapest loop iteration is the one that never happens. And when the connector can't filter the way you need, still prefer expressions that shape the dataset once rather than action patterns that explode per item. Select, join, coalesce, equals, and substring operations don't need to be actions in many cases. They can be computed inline. This is where teams get nervous about readability, and that fear is valid. Expression-heavy flows can become cryptic. People paste a terrifying formula into a field and call it optimized. Then nobody understands it, and the next person adds another condition block to avoid touching it. So the governance rule here isn't be clever, it's standardize. If the organization is going to use expressions to reduce actions, then it also needs standards. Naming conventions for compose outputs when you truly need them, a small set of approved expression patterns, and a bias towards simple, repeatable constructs over one-liners that require a decoder ring. In architectural terms, expressions before actions is not a micro-optimization, it's capacity control. Every unnecessary action is a small leak. 1,000 small leaks is how tenants get noisy, run histories get unreadable, and throttling becomes weekly folklore. And it directly connects back to intent decision execution. Expressions belong in orchestration and decision shaping. Normalize inputs, compute decision outputs, build payloads. Actions belong in execution units. Side effects with receipts. When you keep that boundary clean, you get a flow that runs faster, costs less, and fails in fewer places. More importantly, you get a run history that tells the truth. What did we decide and what did we execute? And that's the point. Optimization that destroys explainability isn't excellence. It's just faster entropy. Next, the problem that quietly amplifies all the others, nesting. Because once you can reduce actions, you also need to reduce depth, or you'll still be debugging like an archaeologist. Pattern. Flatten nesting to restore explainability. Nesting is the tax you pay when you let the canvas think for you. Conditions inside loops, loops inside conditions, scopes inside switches, and then a try-catch scope wrapped around the whole thing because somebody got tired of seeing red failures in run history. It looks organized. It isn't. Nesting hides execution shape, and once execution shape is hidden, you lose the only thing that matters in operations, the ability to explain what happened without interpreting a maze. That distinction matters. A deeply nested flow can still work, but it stops being explainable. And once it stops being explainable, mean time to explain rises, ownership evaporates, and every incident becomes a debate about which container did what. Flattening nesting is how you take that power back. The goal isn't to eliminate all containers. The goal is to make the run shape readable, predictable, stable, so a human can scan a run and understand what did we decide, what did we do, and where did it fail. Here's the foundational misunderstanding. Makers think nesting is structure. It's not. Nesting is opacity. So the first move is path collapse. Pull common work out of branches. If both sides of a condition do the same 4 actions and only differ in one value, that condition doesn't deserve 2 branches with duplicated execution. Compute the differing value once, then run the common actions once. You just removed duplication, reduced drift, and collapsed two run shapes into one. Same idea with switches. If the switch is only choosing which field to write, the switch belongs in data shaping, not in execution. The switch should output an action plan or a payload shape. Execution should remain linear. The second move is to get conditions out of loops. A condition inside an apply to each is not one condition. It's n conditions multiplied by your item count. That's how API budgets die quietly. Not from one big mistake, from one small condition that got replicated 1,000 times at runtime. So instead, split the dataset first. Filter upstream using query options where you can. If you can't, use select and filter array once outside the loop to create two arrays, items that need work and items that don't. Then loop only what needs work with no internal condition. This is the concurrent conditions idea in practice. Organize first, execute second. Everything becomes easier. Fewer actions per item, fewer container expansions during debugging, and a run history where pass and fail are separate narratives, not interleaved archaeology. The third move is to stop using scopes as emotional support. Scopes are useful for grouping a transaction boundary and for controlling run-after behavior. But when scopes become the default way to organize, you create hidden life cycles, actions that only exist inside a scope that only exists inside a branch that only runs in one case. Then somebody adds another configure run after to handle an exception, and now the flow's real logic is encoded in edge case execution semantics nobody can see without clicking through menus. That's not engineering, that's conditional chaos with extra steps. Flattening means use scopes sparingly, only where a transaction boundary exists. If a scope doesn't represent a transaction, it's probably just hiding complexity. The fourth move is to make termination visible and singular. Deep nesting often creates multiple endpoints. Termination actions sprinkled across branches, scopes, and loops. That makes it impossible to answer a basic question during an incident. Did this run complete cleanly, or did it exit early because it hit an escape condition? A flattened flow has one endpoint and one clear termination pattern. Early exits happen through explicit escape hatches that terminate with a reason, and the rest of the flow continues on a single dominant path. That gives you explainability back, and it aligns perfectly with direct path. One narrative, one shape, one place to look for what happened. Now the counterintuitive part. Flattening doesn't necessarily mean fewer actions on the canvas. Sometimes it increases visible steps because you're pulling things out of containers and making them explicit. But operationally, it reduces complexity because you've reduced depth, reduced run shape variation, and reduced the number of hidden behaviors that only show up at runtime. Executives don't care about nesting. They care about predictability. Architects care about nesting because nesting is how complexity becomes unbounded. So treat nesting as a budget. Every container you add must earn its existence by creating clarity, not by hiding mess. And when you enforce that, the estate becomes explainable again, which means governance can finally measure something real instead of counting flows and pretending that's control. Control plane, KPI dashboard, metrics executives can actually use. Here's the part most governance programs skip. Then they act confused when governance becomes a vibe instead of a mechanism. If you can't measure the control plane, you can't steer it. You can only react to whatever broke last. So the KPI dashboard can't be a maker leaderboard. It can't be number of flows. It can't be how many runs. And activity is not excellence. Activity is entropy with a graph. The dashboard has one job: translate architecture into executive-safe signals. Start with the primary metric, mean time to explain. MTTE, not mean time to resolve. That comes later. MTTE is how long it takes a competent person to answer one question during an incident. What did this automation do and why? If MTTE is high, everything else is theater. You can't do reliable incident response, you can't do audit defense, and you can't do change control because you can't predict impact. And MTTE isn't a platform limitation, it's a design outcome. Direct path lowers it, flattened nesting lowers it, thin orchestration lowers it, execution units lower it, orphaned megaflows raise it. So you measure MTTE as a health signal, median and 95th percentile, by environment and by business domain. You don't need perfect math, you need directional truth. Second, ownership coverage. What percentage of automations have a named business owner and a named technical owner plus an escalation path? Not who created it. Owner means accountable for intent and accountable for execution. If the percentage isn't near total for anything running in production, you don't have an automation program. You have distributed risk with plausible deniability. And you can make this measurable fast. Runs in last 30 days versus has owner metadata. Anything that runs and has no owner is an entropy generator. It should be quarantined, reassigned, or killed. Third, deterministic gates coverage. This is the metric that proves you actually adopted intent, decision, execution instead of talking about it. What percentage of side effects occur inside execution units you can audit? In plain terms, how many writes, sends, creates, and approvals happen behind child flows or explicit execution boundaries versus directly inside orchestration logic. This can be rough. You're not writing a dissertation, you're building a steering signal. Are we consolidating authority into governable seams, or are we still letting every maker embed side effects wherever the canvas made it convenient? Fourth, retry rate versus failure rate. These are not the same thing, and most dashboards treat them as one red number. Failure rate is how often did the automation not achieve its intended outcome? Retry rate is how often did you have to reattempt execution to get a success signal? High failure with low retries means brittle dependencies or broken logic. Low failure with high retries means churn. You're burning capacity and API calls to compensate for instability, and you're probably generating duplicates unless idempotency exists. That distinction matters because retry policy is an executive decision. It's literally cost versus latency versus reliability. If teams set retries by habit, the organization is letting developers allocate capacity budgets without accountability. Fifth, API budget adherence. If you take nothing else from this episode, take this. APIs are shared capacity. They are a governance surface. They are a cost surface. They are a stability surface. So you measure call volume per automation, peak call rate, and budget breaches. You don't need to shame teams. You need to detect runaway execution pathways, loops that exploded, triggers that are too permissive, retries that turned into storms. And when a budget is breached, the response shouldn't be increase the limit. The response should be architectural. Fix trigger conditions, terminate early, flatten nesting, move work to expressions, or split execution into bounded units. Finally, explainability coverage. What percentage of production automations stamp a correlation ID and emit receipts you can tie back to a business transaction? Because audit isn't about logs, audit is about evidence. Executives don't need to see every run. They need confidence that when something goes wrong, the organization can explain it, prove it, and correct it without guessing. This dashboard is how you make governance real, not by adding more meetings, by making the control plane measurable, so architecture stops being preference and starts being a managed system. And once you can measure it, you can enforce it with artifacts. That's next. Reference architecture plus before-after map. At this point, the mental model is established. Intent, decision, execution. Direct path, thin orchestration, thick execution. Transaction semantics, metrics that measure explainability, not activity. Now, the only question that matters is whether this becomes a picture the organization can enforce. So here's the reference architecture, not as a vendor diagram. As a control plane map, you can hand to a platform team, an audit team, and a delivery team, and everyone can agree what good looks like. Start with the before map, because it's the one most tenants already have. One massive orchestration flow sits in the middle like a nervous system with no spine. It triggers on everything. It branches immediately. It mixes decisioning with execution because the easiest place to decide is right before you act. Connections are shared and personal. Authority is implicit. Whoever owns the connector owns the blast radius. Retries are scattered in line because try again feels like reliability. Logging is inconsistent because each branch did its own thing, and the run history looks like a choose-your-own-adventure novel written by 5 different people. That's not an automation estate. That's distributed side effects with a UI. Now the aftermap. It has 3 layers, and each layer has a different job. Layer 1 is the orchestration flow. 1 entry, 1 endpoint. Minimal nesting. It stamps correlation immediately. It validates the contract. It produces a decision artifact, root, risk tier, action list, whatever you use to express intent as data. Then it delegates. It does not perform side effects directly. Layer 2 is decisioning, and this is where AI and classification can live without contaminating execution. If you use Copilot, a classifier, or an agent, it produces outputs. It does not write records. It does not send emails. It does not create tickets. It does not approve anything. It only answers the question, what should happen, and under which constraints. Layer 3 is execution. Child flows as execution units, deterministic, idempotent, receipt producing. Each unit owns a side effect boundary and returns evidence, record IDs, ticket numbers, message IDs, and a status you can interpret. Retries live here because retries are only safe where idempotency exists. Compensation lives here because partial success is inevitable in distributed systems. If you want the simplest visual, the before map is a tangled ball. The aftermap is a straight line with a few callable blocks. That's path collapse. And path collapse is the real output of this episode. Because once the path collapses, everything else becomes enforceable. Ownership, budgets, audit trails, kill switches, and change control. Now add the control plane reality most people ignore, connectors and identity. In the before map, the connector is a convenience. In the after map, the connector is an authority boundary. Execution units should use controlled identities, service accounts, service principals, managed identities where available, and connection references that can be rotated and audited. Orchestration should not depend on a human's delegated access to production systems. That's not automation, that's a resignation letter waiting to happen. The architecture also needs zones because one set of rules is how governance dies. A green zone exists for experimentation, personal productivity, prototypes, scaffolding, learning. It has guardrails, but it's optimized for speed. And it has an expiry model because prototypes should die if they don't graduate. An enterprise zone exists for execution, production automations with side effects. That zone requires the patterns: direct path shape, thin orchestration, execution units, explicit identities, API budgets, and an ownership model that survives staff churn. This is where the keyline belongs because it stops governance from becoming performative. These artifacts aren't documentation, they are enforcement surfaces. A reference architecture is an enforcement surface because it defines allowed shapes. A before-after map is an enforcement surface because it makes drift visible. A control plane KPI dashboard is an enforcement surface because it makes outcomes measurable. Zoned governance is an enforcement surface because it lets you say yes to experimentation without letting it become production by accident. And once you have this, you can stop arguing about best practices. You can just ask one question: does this automation conform to the reference architecture of the zone it's running in? If the answer is no, it doesn't ship. Not because someone is mean, because the system will eventually extract payment and it always collects with interest. Next, this gets real with a case. Explainable automation beats smart automation every time. Case study. Explainable automation beats smart automation. A global services organization built an intake automation to route requests and update downstream systems, ITSM tickets, a Dataverse tracker, and a couple of line of business APIs. It started as a reasonable goal: reduce manual triage and speed up fulfillment. Then Copilot arrived. So they did what everyone does. They embedded smart classification directly into the flow and let it drive execution. The orchestration flow triggered on every request, branched immediately into routing logic, then performed the writes in line: create ticket, update Dataverse, notify teams, email the requester, and sometimes open an approval. Retries were sprinkled everywhere because it improved reliability. Ownership was fuzzy because the flow touched multiple domains, so everyone assumed someone else owned it. It worked until it didn't. They started seeing intermittent latency spikes during peak hours. Sometimes the ticket was created, but the Dataverse record failed. Sometimes the Dataverse record existed, but the Teams message didn't. Sometimes the flow failed, but still sent the customer email, so support got a follow-up for work that never actually happened. And when incidents hit, the run history was a forensic exercise. Dozens of branches, nested scopes, and run-after behavior that encoded policy in places nobody remembered. MTTE wasn't an hour. It was multiple days because nobody could answer the first question: what did this run actually do? So they didn't rewrite the automation. They changed the architecture. First, they separated decision from execution. The decision layer produced a classification output only: intent category, priority, required actions, and risk tier. That output was logged as data with a correlation ID. It did not write to downstream systems. It did not send notifications. It did not create tickets. It simply produced a decision artifact that could be reviewed later. Then they rebuilt the orchestration flow as thin: one path, one endpoint, validate the input, stamp correlation, call decisioning, then delegate to execution units based on the decision artifact. No branching explosion, no inline side effects. Finally, they pushed every side effect into deterministic child flows: execution units with transaction identity, idempotency, receipts, and bounded retry policy. Create ITSM ticket, returned a ticket number. Write Dataverse record, returned a record ID. Notify teams, returned a message ID. Each unit wrote evidence back to a single log surface keyed by correlation ID so they could answer what happened without scrolling through a maze. The outcomes weren't magical, they were mechanical. Latency dropped materially because they removed redundant connector calls and stopped retry storms from competing with legitimate work. Failure rate dropped because side effects became idempotent and compensation paths existed for partial success. MTTE dropped from multi-day interpretation to under an hour because the run shape became stable and the evidence became searchable. And costs dropped because API churn stopped being treated as an acceptable tax for reliability. The proof point wasn't that the automation became smarter, it became explainable. And explainable systems are the only ones that survive audits, outages, and executive scrutiny. Conclusion. Excellence comes from separating probabilistic decisioning from deterministic execution, then enforcing that boundary with architecture you can audit. In the next 30 days, mandate execution-only child flows for all side effects, set explicit API budgets with retry limits as policy, and run an automation review board that checks ownership, authority, and a real kill switch before anything ships. If you want the templates and patterns, connect with Mirko Peters on LinkedIn and leave a review on the podcast with what you want next: agents, CMK, tenant isolation, or COE metrics.